All right, Unit 3, Lesson 3, which is Chapter 9, Section 3 in the book. Let's do a little warm-up on quadratic equations. Quadratic equation is equation to the second degree, meaning it contains at least one term that is squared. When solving quadratic equations, we use factoring, the even or square root property. These methods work for some equations, but not all. Try to use either method to solve the following. So we've learned quite a few things here. This one, I believe, factors. Go right to the guess and check. Because it's a plus plus, it factors to a plus plus in its answer. Factors of 6 that add to 5 would be 2 and 3, not 1 and 6, because that would add to 7. So it must be a 2 and a 3, and it doesn't matter where I put them because 2 times 3 is 6, and 2x plus 3x equals 5. So either way is fine. Then use the zero rule property that says you set the factors equal to 0 because one of them has to equal 0. Solve for x, so x equals -2 or -3. So 2 solutions for that one. So that's by factoring. This one is set up to use the square root property, so don't FOIL it out. Don't write it twice and FOIL it. Go ahead and use the square root property. It's easier. If you forget that, it will come out to the same thing, but let's do the shortcut way. If that's a 2, then we take the square root of both sides. You get the root, and since this is an even index or an even exponent, we're going to go with it's the index, I guess, plus or minus the square root of 18. And 18 is the square root of 9 and the square root of 2, and then we're going to move the 5 over. So x equals -5 plus or minus 3 square root of 2. Okay. So -5 plus 3 square root of 2, -5 minus 3 square root of 2. So notice because of that answer, it definitely wouldn't factor. So you have to either write down x plus 5 twice, FOIL it, bring the 18 over, and solve for x that way, or this way is the square root property is much easier, okay? This one looks a little strange. I don't have an x. If I move the 13 over, that's going to be x squared plus 18, which isn't a perfect square, and it's not going to factor. It's going to be prime. So if I move the 5 this way and isolate my square, I will do that. That's going to be an 8. So since this is something squared, I can take the square root of both sides. And because it's not a Pythagorean theorem problem, it's an even root, it's plus or minus the square root of 8. Square root of 8 is square root of 4, square root of 2. So x equals plus or minus 2 square root of 2. 2 square root of 2 or -2 square root of 2. Okay. All right, this one here, let's see. Factors of 7 are 7 and 1. There's no way to get a 2 out of that. I don't have a square. If I move the 2x and the 7 to the other side to isolate my x, that's not going to work either. So it turns out the square root property and factoring doesn't work for that one. Okay, so we are in need of another one, another method. So here is completing the square for this section, and the next section we're going to have the quadratic formula. So we're going to get 2 more methods. So this is one of them, called the square root, completing the square method. All right, so it says use the formula b over 2 squared to change the quadratic into a perfect square, factor, and then solve using the square root property. So it wants you to take a step. when you're using the completing square method, so you can fix the problem, so you can use the other methods to solve. Okay, that's what this is doing. So completing the square is the one recommended method of solving quadratic equations in standard form when a equals 1 and cannot be factored. So since you're going to, by the time you're done this unit, you're going to have 4 different methods to handle your quadratics. So this one is one that's a choice when the equation can't be factored and a equals 1. I think we're going to run into a couple examples where a doesn't equal 1, but we can fix that. So let's see how this works. So step 1, make sure that your quadratic equation is in standard form. Some books call that general form. Either way, that's what it looks like. I need the squared term first, then the term with one variable, and then the constant term, and it has to equal 0. So make sure you get everything moves so 0 equals one side, like you would if you were factoring, okay? Or, yes, if you were factoring. Then it says move C to the other side by adding its opposite. So if you have a -2, move it over and make it a +2 to make it go away from this side, okay? And it's just a coincidence that this one did the same thing, okay? Got that third term out of the way, because if you notice, this isn't going to factor, okay? There's no combination that would just plain factor with these, even though the numbers are small, but you can see that. Because of the negative, it's going to be a negative and a positive, and there's no way to get a -3 out of that. So it wouldn't have factored, okay? So step 1, make sure it's in standard form, then move C over to the other side, getting it out of the way. Then you use B to find a new C. Okay, so notice that this part is still the same, and then you take this part right here, this -3, and put it over a 2. That's why it says B over 2, and then put a square, right? So this is what's going on here. And because it's an equation, this whole thing here needs to be put onto this side with the 2 that was there, okay? And I know that's kind of complicated, but what you're trying to do is make a perfect square on that side. -3 over 2 squared is a 9 over 4, but on this side, because of what we did, let me get this looks very messy. Because of what we did, whatever's here, whatever inside here, you can put right here. So ignore that square right here. Right here, you're kind of making, you're making something that factors. You are making something that factors, even though it's got a fraction in it. Here, let's look at one. This other one looks a little more simple. So the middle term is 6, right? B is 6. Put the B over the 2. That's going to make a 3. Squared is a +9, okay? So basically you're adding 9 to both sides, and you made this something that will factor, okay, because you have put a root on the end. So x plus 3 times x plus 3 will give you the x squared here, okay? So add these two together here. Let me keep going on this example. This one looks easier. That makes 11, and then you're supposed to use the square root property that says take the root of both sides, and because it's an even root, you want the plus or minus there. Then you need to move the 3 over to the other side by subtracting 3, so you're going to get this, which gives you this and this for an answer, okay? So this is what this example number 1 over here is what happens when B is not an even number. You're going to get fractions all over the place, okay? So when B is not an even number, when you have all 4 methods available to you, this one I would probably do the quadratic formula for, which is in the next section, I believe. But this is an example because you're going to get ones like these that don't have an even B. So it's going to make a fraction. What's inside the parentheses comes down here, and then the whole thing, though, gets calculated out think of this. This is the square of -3 is 9. The square of 2 is 4. So that's fraction, okay? Then you have to add 2. How do you add 2 to 9/4 besides using your calculator? Well, what is 2 in terms of 4? That's 8, right? 8/4 is a 2. So that gets you your 17/4. And then this is a square, so we're going to take the square root of both sides using the square root property, which will leave you what was inside the parentheses left. And you have to plus or minus because it was an even root for your fraction on this side. Okay, the 4, recognize the 4 is a perfect square, so go ahead and look at this as the square root of 17 over the square root of 4, which will get you that. Move this term to the other side by adding 3/2 either side, so you get that there, and this is your final answer for that one. So that is how to handle a fraction because your b is not even, okay? So the only thing we learned different here is instead of getting this x squared alone on one side, because of this x here, this is not going to factor, and it's not going to use the square root property. So this is how you do completing the square. Let's see if we can do, let's do 1 just to double check, and then I'll make another video with the rest of them, okay? So here's a quadratic in the proper order. My x squared is first, then my x term, then my constant term, and it equals 0, okay? It says if a is greater than 1, clear by dividing by that to reduce away the a. So this one I don't have to do that for. So my first step is to move the 33 to the other side. And then I'm going to take my b, which is an even number here, and put it over a 2 squared equals 33. And whatever I put over here, I'm going to put over here, okay? And what is that equal to? -8/2 squared is what? It's going to be 16, because think about it. This is going to be the same as -4. Process this however you need to get the number. So this is going to be x squared minus 18x plus 16 equals 33 plus 16. This is going to factor out. Okay, so this is going to factor. So we don't want to move this stuff. We don't want to move this side that way. We want to factor this as it is. We just went through a lot of trouble to make it a good. So x squared. It's not going to be x squared anymore. Hang on. All right. So let's make x minus 4. Remember, I said this little bit right here goes here. Okay, and what does this equal? This equals 49. All right, so now we can do the square root of this and square root of that. Use the square root property, the even root property. Get the root by itself, and because it's even, it's plus or minus the square root of 49, which is 7. X minus, oops, I need to move the 4 over. Hang on. All right, so to finish this up, x equals 4 plus 7 and 4 minus 7. That's my final answer for this one. Okay, I want to do a video for the rest.